Okay, all right. So now that we know both methods, there's a mixture of both methods on the sheet. So if I wanted to use shell method, since I'm rotating around something parallel to the x-axis, it would have to be integral dy. Do I want integral dy? I mean, these are easier to handle, but do you want to solve these for x? Do you want to? You're all like, what's the right answer? I don't want to. How's that? Does that help? I don't want to. I don't want to. I'd rather leave them there in terms of x and they look fine, right? So maybe I don't want to use shell method. Let me see if disk method will work. And if I start to do it and I run into trouble, like I get a function I can't integrate, then I backtrack and set up the shell method. I mean, that's, again, failure is going to be a possible step in this process. It's not really failure, it's just checking out to see if it works. It didn't work, shit, let me go to the other one. So if I try to set up disk method, officially I'll have to be washer method. What do I have to identify?
Your inner.
Yeah, inner outer radius, I like it. So this will be integral dx. So my inner radius, I always start at the rotation axis. It makes sense because that's the center. And how far out do I go? I stop at this one, which is f. So what's bigger here, the axis or the function? The function's bigger. Cool. So the inner radius is going to be function minus axis. And that axis is, of course, what's this axis? What's this line? -2. There it is. So I get the inner radius is x squared plus 5. Cool. You guys see what I did there? Who's bigger? Who's smaller? That tells me how to subtract. Right? It's not that big of a deal. I'm trying to address all the issues that I know students have. Also remembering the issues I had when I learned this shit. Because my teacher sucked. I'm like, if only he would have said this shit, maybe I would have been better. So what about the outer radius? So again, start here, go all the way out until you hit the outer edge. So what's my outer radius? Yeah, so it'll be 11 minus x squared, that's bigger, minus -2. So it'll be 13 minus x squared. So basically both of them are 2 bigger than they would have been. I mean, there's a whole other way to look at this. But I want to show you the really technical way, just in case I have funky locations of functions and axes. You can always fall back on this. But it's just going to be 2 bigger than it normally would be. And that's what we just found. It's 2 bigger than it was. That's 2 bigger than it was. Because my axis is 2 steps further away than it normally would be. I love the look. I get so many different perplexed looks. All right. So now, what do I put on the outside for this method? Pi. Good. Because this is based on areas of circles.
-2 to 2.
I like it. So this is dx. Now, in this case, you have to be really careful. But in this case, could you go from 0 to 2, for example, and then double it?
Yeah,
Symmetric, so you can do it.
It's got to be symmetric in all ways. So it's everything is the same distance away from this, and it's symmetric in this way too, because I want to break it up 0 to 2, right? So you got to be really careful. In fact, part of me just doesn't want to let you do it. So let's try to do it this way. Kevin, if you want to, you can try to do the other one. Let's see if we get the same answer.
Oh, crap.
Kevin's like, I'm okay then. So what I put in here?
Outer minus.
Yeah, it's always outer minus inner, bigger minus smaller.
13 minus x square.
Now we're back to the FOIL thing that we're going, minus
X squared plus 5 squared.
x squared plus 5 squared. Good. Learn from me. Give yourself more room. Or just don't use pen. Alright, and we're at the easy spot here, right? Poor Kevin is working away, but Do I really? I mean, you could FOIL this out, integrate the polynomial, not a big deal. Yes, no, maybe so. All right. Does it really want you to do number 2? Are you guys really cool with that? No? So what's up, Steve? You just yeah, I should know better than to take that for you. Okay. Every now and then you're being honest. That came out wrong. So try number 2. You might be able to guess what method I'm going to want you to use here, but let's see. This one's a little different because I only give you one function, but I say in the first quadrant. So if you kind of sketch that whole function, you just focus on the part that is actually in the first quadrant. You see how quickly you can eliminate disk method. If I'm going around the y-axis, the disk method would require integral dy. So my function would have to be in terms of y. You should all very quickly agree you cannot solve that for x. You cannot. You cannot. Please take that as a challenge and try. But no, you can't. So I'd much rather use a method that would allow me to have my integral be dx. Do you guys get the feel of how to look at these things? So I can't use disk method, so now I focus all my attention on shell method. What does shell method need from me? Keep going.
And that's how you choose on whether...
Exactly. That's how you choose with which method. There are certain functions that would work either way, and if you did it one way, the integral would be easier. But I always say if it works either way, just pick the one you think of first. Because otherwise you're wasting time checking them both out, you know? Does that make sense? So there are going to be functions that will work either way. For sure. Let me see if you guys figure out what you need to do with it. I mean, being bounded by the first quadrant basically means being bounded either by the y or the x-axis. And this will most likely be x-axis. So if I find this guy's what do I need to find for this guy then? I mean, if I draw some function, some arbitrary function, what part of the function is in the first quadrant? The part that's between its intercepts. So I need to find this guy's intercepts, x-intercepts.
So equals 0.
Yep. Factor that bad boy. I love it when my calc student comes up and complains to me that I gave him a cube problem to factor. I told that person to turn around and get away from me. You gotta know, dear Jesus, you gotta know how to factor those things, right? It's not even a cube, it's what method to use for that. Groovy.
Thank you.
Sure.
5 and 1 negative 1.
Steve, is that for Casey?
Yes, sir.
Can you take him his... Would he be okay with you?
Yeah.
Alright. So we can start on that first.
5, 1.
So you get 1 minus x plus 1, x minus 5. Is that cool? You get a difference in squares, x minus 5, blah, blah, blah. So where are my x-intercepts? 5,
1.
1,
-1.
negative 1. Who cares about that one? That's not in the first quadrant, right? So now I know this thing is going to look like from 1 to 5. Oops. So just to go, I'm going to put negative 1 back there too. I'm going to focus on this. So it would look like this, that, right? Basically. We got my okay, we got wrong there, but okay, so I'm just going to focus on the part that's in the first quadrant. Cool. I'm like a whale reaching. So I identified, I already eliminated disk method, so I know it's going to be dx, so I know I can leave it like this. Everything's happening on the x-axis then. What do I do right now, though, to keep myself grounded? I like it, so I know it's shell, so I can put the 2 pi there. But on the graph, there's one more thing I want to put on there. A representative rectangle. How far is that? Where's my axis of rotation? The y-axis, right? So how far? So I'm really show you. So what is this radius? And how far do I have to go? I go out as far as whatever that what? X value is. I love it. If my rotation axis would have been x equal -1, it would have been x plus 1. Ooh. Do you guys see what I mean? And that's what I was saying earlier. There will be sometimes you have to foil for shell method if you have an off-axis rotation, right? Maybe. That's where that comes in for shell method, is it changes that radius from x or y to plus or minus something. Maybe. But thankfully I'm not doing that. It's nice and the y-axis. So it'll be 2 pi times the radius times the function. You don't give yourself the room for anything. And what are the limits going to be? 1 to 5. I like it. And again, if you're worried that there's more to this picture, I'm not drawing the whole picture, I know. But as I move, as I go from 1 to 2 to 3 for the x values, that's what this does, right? It goes from 1 to 5. It goes through the whole thing. Each one of those makes its own shell that gets added to the rest of them, right? So this doesn't look like it, but it does represent a 3-dimensional object. It does. It just doesn't look like it. And you've got to ask yourself, what did I expect it to look like? If you don't think it looks like the way it should. But to me, that was one of the hardest things to get down, was it just didn't really feel like what I thought it would feel like to do 3D stuff. Well, if you're going to go to Calc 3, the 3D is going to be in your face. There's going to be no question that it's 3D. I don't know if that makes you feel good or bad or not. Some of you guys are like, thank God I don't have to do that. So now what do? I mean, this is... The rest of it's easy, right? Negative x to the 4th plus 5x cubed plus x squared minus 5x. Integrate. Substitute. Cool. So we'll do this last one next time. We'll probably have a quiz next week. We'll talk about it tomorrow.